In this video, we are going to look at how we can find the coefficient of friction if a horizontal force of 140 Newton is needed to pull a 60 kg box across a horizontal floor at a constant speed. What is the coefficient of friction between the floor and the box? And they want us to determine this to three significant figures. So to do this, we first have to draw a free body diagram, which I'm going to put up so that you see how we can calculate. So now this is our free body diagram. Now that the free body diagram is set up, let's move on and calculate the kinetic of friction, sorry, the coefficient of friction. Before I go anywhere, I need to mention that coefficient of friction is given by the normal force, is given by the friction force, okay? Let me use a capital letter. Given by the friction force over the normal force. So in this context, we first have to find the friction force, then we also find the normal force. Whichever you start with does not matter. Let's start with the normal force because it's easier. All right, so we are going to consider the movement in the y. So let's talk about the y direction. Is this box moving up and down? No, it's not moving up and down. All right, since the box is not moving up and down, acceleration in the y-axis is 0. So if we use Newton's second law of motion, which says the resultant force is equal to mass multiplied by acceleration, this acceleration is 0, so everything here becomes what? 0. Now, the sum of forces in the y-axis, we have this one and this one. What is this one? This is the normal force acting upwards, while this one here is the weight of the box. They are acting in the opposite direction. So here we've got the FW, sorry, not FW, we can't start with that one. We start with this one, the normal force, which is going up. So the normal force is going up, same minus. The weight, which is coming down, we can denote that by negative sign. This is equal to what? 0, because this is 0, so everything becomes 0. So in short, we are saying the normal force is just equal to, take that one, the other side is just equal to the weight. So normal force is, what is the weight? Weight is mass. Mass is given, isn't it? Now, since the mass is given, this is mg. That's how we find weight. So this will be the mass is 60. Gravity is 9.81. So 60 multiplied by 9.81. I'm getting the normal force to be 50 what? Sorry, 588.6 newtons. So we've found one thing. Let's go now and find the friction force. To find the friction force, we are going to consider the motion in the x-axis. So let me do this. We are going to consider the motion in the x axis. So let's talk about the x direction. So in the x direction, we are talking about this force going this side, and the friction force is going in the opposite direction. So the same thing, sum of forces is equal to ma. Now, I want you to note something. What is this? Constant speed. An object moving at constant speed, it means there is no change in speed, so acceleration is 0. Okay? The change in speed is 0, so even the acceleration. So if that means acceleration in the x direction is also what? 0. So now that means what we have here is also what? 0, because if we put 0 times mass, we are still getting 0. So the sum of forces, we're talking about the force, which is this one, and the friction force. So we're talking about the force minus the friction force is equal to 0. That means the force is just equal to the friction force. Right? Now, therefore, we have the force is 140. So we are putting 140 here is equal to the friction force. So friction force is found. We can now use this formula here and say coefficient of friction is equal to, the friction force is 140 newtons and the normal force is 588.6 newtons. So we divide those. So 140 divided by 588.6 is giving me 0.2. Remember they said 3 significant figures, so it will be 0.38. Okay, it's giving me 0.2378, so it can end here. Don't add units, it's done. You're welcome. Subscribe to my YouTube channel and follow for more.